So if I asked you to solve the equation x minus 4 equals 12, I mean, I know you can look at that and use common sense and tell me what the answer is, but what would you do algebraically to find the answer? You'd add 4. Why would you add 4? Like, why not multiply 4, divide by 4? Like, why specifically add? Okay, so it's the opposite of subtracting. Like, that's kind of the key, like, that's the key thing, is that the opposite of subtracting 4 is to add 4, and that's how you isolate the x, okay? So you get x equals 16. All right, so different question. What if I gave you x squared equals 16? Again, you can do the math and you can tell me the answer. I don't doubt that. But algebraically, what do? You square root it. Why do you square root it? Yes, because squaring and square rooting are opposites of each other, or they're inverses of each other, in that they're going to like undo one another. So that's what logs are. Logs are the inverses of exponents, and logs solve problems like this. 10 equals 4 to the x power. Yeah, because there's no way we can figure that out. Like, if I gave you a problem, like if I said 16 equals 4 to the x power, y'all could tell me what x was. Like, you're intelligent people. What would x be in the second problem? 2, because 4 squared would be 16. But if I said solve the first one, you couldn't do that because it's not a whole number. You could guess that it's somewhere between 1 and 2. Like, you could say it's probably like 1.6 or something like that. You could make an educated guess, but you don't mathematically have the ability to solve that. Nobody does, like literally without like guessing and checking. But logs, what they do is they unsolve, they invert, they solve for x, these exponential problems. So if you'll write at the top of your page, I want you to write this. I want you to write that the log base b, now that b is a subscript, okay? That log base b, and it's very important that you write these correctly so that you don't confuse yourself later on and think that something is something that it's not, okay? So the log base b of x equals, hold on, sorry, no, change that. So the log base b of a, my bad, equals x. Sorry. Can be rewritten, or is the same thing as b to the x power equals a. Log base b of a to the x is the same thing as b to the x power equals a. So thinking about the problem I just gave you that we didn't know was I said that I said that 4 to the x power equaled 10. Well, I could rewrite that as the log, what would my base be here? 4, because that was what b was over here, of what would go here, what am I taking the log of? 10. Would equal x. That's something you can plug in your calculator. And then you would end up solving the answer. And we're going to get into that part of it more like Monday. There are no equal signs. We're just kind of working with stuff and we're simplifying it. We're manipulating it. So in order to understand logs, remember logs and exponents are inverses of each other. So that means if we know our exponent rules and we know how to work with exponents, then we know how to work with logs because they're going to be the opposite. So just review our exponent rules. If I have x to the second times x to the third, when I multiply, what do I do with my exponents? You add them. So that means that since they're opposites of each other, that when I'm working with logs, when I add two logs, I actually end up multiplying. So if multiplying means I add my exponents, then adding my logs means I end up multiplying because they're inverses of each other. They're opposites. So, for example, problem 1 down here, I have the log base 2 of 4 plus the log base 2 of 12. So I'm adding two logs, aren't I? So I can turn that into one problem by multiplying. What is 4 times 12? So this is the log base 2 of 48. So I took my 4 and my 12 and I multiplied them together to get me my 48.
What is so?
We'll get to that.
What is so log? So log the base 2 that kind of acts as like the x. I think the same kind of.
It acts like as yes, like in comparing it to this problem here, this log base 2. So what Abby was saying was this 2 here is like my base here of x's. It doesn't change. It stays the same. So yes, ma'am. Trinity, what was your question?
Does the logs on the bases I meant, do those have to be the same?
Yes, my bases do have to be the same, and we're going to talk about that when we get to problem 3. We have some different bases down there. Okay? All right, so let's go ahead and do problem 3. I actually like problem 3 better than problem 2. So problem 3 says the log base 5 of 3x plus the log base 5 of 2x plus the log base 8 of 4. And as Trinity pointed out, this one is different. So I cannot combine it with the others. Just like if I had the problem x squared times x to the third times y to the fourth, I could not combine all of those together, could I? No, because they have different bases. The same thing is true with my logs. So I can combine what I can combine, and then I leave the rest there. So that means that since I have 2 that have a log base 5, I can multiply those parts together. So what is 3x times 2x? 6x squared. So this will be the log base 5 of 6x squared. And then I'm still going to have plus log base 8 of 4. It's a terrible looking 8. There we go. And there's nothing else that I can do to simplify that problem. Now, one of the things I told you guys was that we're going to do the foundation of this today, and that's what we're going to do. I got it. Is that we're going to start this today, but we will actually do the rest of the simplifying part on Monday. So our next one, so okay, when you divide, let's review that. So if I had like x to the 7th divided by x to the 4th, what do I do with my exponents there? Subtract. So that would be x to the 3rd. So then using the inverse of that, then with logs, when I have subtraction, that means I divide. All right, so I have the, number 1, I have the log base 2 of 35 minus the log base 2 of 7. So what can I do with 35 and 7 here? Divide. And what's 35 divided by 7?
5.
Yes, so this would be the log base 2 of 5. That'd be your answer. Okay. Look at problem 2. So it looks confusing because you have a lot of minuses in here. But here's really what you need to know. That if you have a minus sign, all it means is that that part of the problem is in the denominator. So 8x to the 4th, was that part here, was that in front of it, was that positive or negative? Positive, so that's going to go on the top. Let's try that again. 8x to the 4th. Okay. What about this log base 8 of x? Where's that x going to end up at? In the bottom, because it is negative, that means we need to divide by it. And then same rule is going to apply here, that because I have the log base 8 of 2 and that's a minus, that 2 is going to end up in the denominator. So it doesn't actually mean that I'm doing 8x to the 4th divided by x divided by 2. It means I'm dividing by both 2 and x. Okay? Yes, and I still have the log base 8. Sorry. I have the log base 8. And I can simplify that. Like, I can do math with that. And Layla, you said that it'd be 4x cubed. So really my answer to this problem, because I don't want to leave it like that because I can do math, it would be the log of base 8 of 4x cubed. I'm going to put that in parentheses. I just like using parentheses because then that denotes that for sure this entire thing is what I'm taking the log of, not just one part of it. Okay. Number 3, can I combine all of those together?
No.
Can I combine some of them together?
Yes.
Which ones? The first 2. So I'm going to write underneath this because it's going to take a little more space. So I have the log. Yes. It doesn't have to be in parentheses. I just need you to know that entire thing is included with the log. That it's not the log base a to 4, and then you're multiplying that answer by x to the third. It's like the same idea as this being different than this. These two are not the same. So it's just saying like that 4x to the third is just saying that we're taking the log of all of that, not just the 4 and then the x to the third is off on its own. That's it. Okay. So back to our problem at hand. We have the log base 5 of, okay, I've got to have a fraction here. And why do I have to have a fraction? Dividing or subtracting. So what's going to go on top? The first part. 3a to the 5th, b to the 7th. And why does it go on top? Yes, it is positive. Okay. And then I have some stuff that goes in the denominator. What goes in the denominator? And why does that go in the denominator? It's negative. Okay. And then I can't actually do anything with this log base 8 of a, so I'm just going to write minus log base 8 of a. Because I can't combine it with anything else because they have those different bases. Okay. So, can I do some math here?
Yes.
What math can I do?
Divide the 9 by 3.
Okay, so that would reduce to what? 1/3. Do I have to write that 1 on top?
No.
No, you can. You don't have to. Okay, what about my A's? 2 where?
5 minus 3.
Yes. Okay, what about my B's?
2 on the bottom.
It ended up being 2 on the bottom. So if you did 7 minus 9, you would get negative 2, and that's fine, but we can't have negative exponents. So if they're negative, we move them to like wherever they're not. They're negative in the numerator, move to the denominator. They're negative in the denominator, move them to the numerator. And then I'd still have that minus log base 8 of a. So that would be our answer there. Just can't do anything else with it. Okay, the actual rule here says that if I have the log base b of, we'll say m, why not, minus the log base b of n, then I can rewrite that as the log base b of m divided by n. Okay, and then the last of our exponent rules says that if I have powers to powers, what do you do with your exponents when you have powers to powers? Like if I had x to the 4th to the 3rd power, what would I do with my exponents? You multiply them. This becomes a multiplication. This would be x to the 12th. So when I have power to power, you multiply. So that means that when I have a log with an exponent, this is interesting, it means that the exponent becomes the coefficient. Means the exponent becomes the coefficient. So if I have, for the rule, the log base b of x to the y power, then that is the same thing as saying y times the log base b of x. So I can take my y and I can bring it down in front. That also means I could do the opposite and I could take a coefficient and I could move it and make it into an exponent as well. I can do either one. So problem 1, how could I rewrite that? Yep, I could do x times the log base 2 of 4. Okay, problem 2. Yep, 4 times log base 8 of 8.
I like that one the best.
Why?
It's so easy.
Yeah. Okay, so 3 log base 5 of b to the 7th would really be 7
The log base
5 of b. We'll get to 4 later. We'll get to 4 next week on Monday. And then we're actually going to come back and we're going to finish this because I'm going to tell you that problems like 1 and 2 can be simplified more. We're not done yet. We got more to do here. But we're going to come back like on Monday. We're actually going to bring these back out and we're going to learn some other rules that apply here. So right now we're just kind of learning how to manipulate them. But then we're going to learn what really happens right here and what this means. Because this one's 2 is a unique problem. Why is 2 unique? Yeah, I had this whole 8 and 8 thing here. That's kind of unique. And then this is 4 I could divide by 2 maybe. So we're going to talk about what all this means. So let's look at the last 3 problems we have on our notes. And we're going to apply all those properties of logs that we just learned to make these problems look better. And guess what we're going to have to do on problem 3? Factor. We get to factor. Factoring does not disappear. It's still here. It is still your friend.
Who's my friend? It solved itself.
Yeah, you'll be fine. Okay, so a couple things you need to know. Just write some stuff to write on the side here. That if you have the log of x, if you have just like the log of x, that's the same thing as the log base 10 of x. So if there's no base that's given, that means it's a base 10. Just want to talk about that because you're going to see some problems that just have log and you're like, wait, log of what? Log base what? It's base 10. It defaults to that. Okay. If you were to write the log base e of x. Have we seen e before?
Yes.
Do y'all remember what we said about it?
It was like pi. It had a set number.
Yes, it's like constant like pi. It is like 2.71 blah, 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 blah. Okay, that's the same thing as ln of x. That's what that means. That is an L. It stands for natural log. Yeah. So that's why that's why I want to talk about that. That ln of x is really like saying log base e of x. We just call it the natural log. Okay? So those are just 2 things you need to know. Look at I want to do problem 3 with you. What do you think we need to do first? Factor. Okay, so that it gives me the log base 3 of, how do I factor x squared plus 6x plus 8? Okay, x plus 2, x plus 4, or x plus 4, x plus 2, it doesn't matter. They're the same thing. Okay, plus the log base 3 of, can I factor x squared minus 9?
Yes.
How?
Yes, minus 3x plus 3.
Okay. All right, and then minus the log base 3 of,
X plus 3, x plus 2.
yes. Okay, well now I can write that as actually one big problem. So I'll have the log base 3 of, and I got a bunch of stuff that's going to go on top. What's going to go on top?
X plus 4,
Yes, all of those factors in the first 2 parts, the x plus 2, the x plus 4, the x minus 3, and the x plus 3 are all in the numerator. And then in the denominator, X plus 2 and x plus 3. Why do those two go in the denominator? Yes, because I was subtracting. Yeah, and then I can do some canceling. Yeah, so the x plus 2's cancel and the x plus 3's cancel. So I just end up with the log base 3 of x plus 4 times x minus 3. You can leave it like that or you can multiply it back out, either one. Okay?